so let's look at numbers 1 through 4. Okay, we're being asked to either sketch or analyze a picture, and then listing the components, the magnitude, which we've seen with this notation, and the directional angle in reference to the unit circle. Okay, so let's look at the first one. A, if you notice, A has a x 1, 2, 3, 4, 5. It has a positive 5 change in x, and then it has a 1, 2, 3, 4 up 4. So if this was a point, we'd put parentheses and you would just see a point there and nothing else. But because of the fact that you see an actual vector, okay, so this arrowish line, if you will, again, it has a starting point and it has an ending point. This is not going to be with parentheses as far as notation goes. It's going to be shown as a vector. So sideways V's, if you will, for vector. These are the components for what you just saw with vector A. So B, we always do the x first. 1, 2 to the left. So it's going to be a negative 2. Then up 1, 2, 3, 4, 5, 6, all the way to the arrow. So negative 2, 6 will be the components of vector B. Okay. And then 6, negative 3. So we're going to go to the right, since it's a positive 6, from an original point. So I could start here if I wanted, and I could go 1, 2, 3, 4, 5, 6 to the right, and then 1, 2, 3 down. So I'm going to show just the vector as far as what is the pathway that this vector is going to take. Again, the same thing. You're going to have an initial value or initial starting point, and then an arrow showing what direction that vector is actually traveling at. Okay, so this is going to be vector 6, negative 3. But because of the fact that it doesn't really matter where the vector starts, you could have started here if you wanted. Okay, and you would have had 1, 2, 3, 4, 5, 6, then down 3, and the vector would have looked like this. Notice that they are parallel. It just starts in a different direction. But ultimately, what is the same is the direction and the magnitude. Okay, the direction being that angle and the magnitude being the length of the actual vector. Okay, so let's get the magnitude. If you recall that the magnitude is going to be looking at the components, and it's basically just going to do Pythagorean theorem. It's going to be the x squared plus the y value squared, and then we take the square root of that. Okay, and when you do that, you're going to get something like 25 plus 16. And when you take the square root of that, it's approximately going to be about 6.4. Okay, so let me go ahead and write that. So 25, that's 31, 41. Okay, and the square root of 41, let's say we're going to go ahead and do these in decimals. It's going to be the following. The square root of 41 is about 6.4. Let's go up. Whoops. Let's go up just to see if there are more decimal points. Not there, but just one. And there are. So 6.403 is what I want. 6.403 is a good approximation to do 3 decimal places. Okay, so if we do the negative 2 and the 6, please make sure to put the parentheses around the negative. Otherwise, it will change your answer to something incorrect. So since this value was a negative 2, make sure you put the negative on the inside of the parentheses, not the outside of the parentheses. So that you should get positive 4 plus 36, which is root 40. And yes, we could write root 40. Or the way we've been doing in the unit, we could write approximately 3 decimal places. And let's see what we get there. So the square root of 40, we'll get control answer and go up. See how many decimals? So it'd be 325 if we round up. So 6.325. And let's put units, just a reminder. So on these problems, these word problems, they could be feet, they could be miles, they could be miles per hour. We have to remember with magnitude to put units. And direction, degrees. Okay, so let's do this last one. So to be 6 squared, again, negative 3 is going to be on the inside of the parentheses. So we have 36 plus 9, okay? And 36 plus 9 is root 45. And let's see what we get with root 45 to 3 decimal places. Okay, so root 45 in the calculator is going to give us the root 45, 45, and then we get something that looks like 708. So 6.708 units. So we'll just put UN for units. Unless it had feet, you put FT, so on and so forth. Miles, you put MI, and so on and so forth. All right. So this one, or the last piece that we're going to look at is the directional angle, and this is like unit circle. So that means here's 0 degrees, here's 90, here's 180, and here's 270. This is a big reason why we had you guys memorize the unit circle, so that these applications with real world problems could seem a lot easier to deal with. Okay, so what we've been using is the arctangent of y over x. And in this case, you're going to look at the components and you're going to put the y of 4 over the x of 5. So you have something that looks like that. Okay, so the arctangent of 4 over 5, let's go to our calculator. I'm going to change it to degree mode just to make sure. So home 5, 2. Change it to degree and make it your default. Let's go pressing 4 to go back to our current document. And again, we're going to do the arctangent of 4 over 5. So the arctangent is here. Whoops, something's stuck. So let's clear that real quick. And then let's try again. The arctangent, and it's going to be the arctangent of 4 over 5. So control divide 4 over 5, and we'll say that answer is 38.7. Okay, so 38.7. Right here, there is a rule that we have to remember. Depending upon what quadrant our components represent, that will tell us what we're going to do with this angle that we got here in the calculator. Okay, so if I told you 5, 4, just 5, 4 written as a component vector, and I asked you what quadrant would this be? Well, if you just started here at the origin and again traveled positive 5 and up 4, then it's shooting out into quadrant 1. And in quadrant 1 and 4, you're going to leave those as is. Okay? It's only in quadrants 2 and 3 that you actually, whatever it is that you get here, you're going to add 180 to that. Okay, so it'll be like 1, or it'll be, in this case, the 38.7 that we got, we're going to add 180 to that. Okay, and let's see what we get here. So it'll be, let me go to the calculator. In this case, we're not going to add 180. That's what I'm saying. My bad. That might have been a little bit confusing. Let's back up just a little bit. If this vector showed that it would be in quadrants 2 or 3, then we would add 180. But because of the fact that this vector shows that it's in quadrant 1, we're just going to leave it as is. Exactly what you see, just like you would do if it was in quadrant 4. Whatever it is that you get here, you're going to write as your directional angle. Okay, so let's go ahead and go to our sheet here, and let's go ahead and write that in. We're going to write the angle theta is that 38.7. Let's see if we have more decimal numbers. So 659. This 8 will make the 9 round up, so we're going to have 660. So 38.660 degrees is the directional angle for that one. Okay, so now let's look at this one. This has a -2, 6. So like I was saying, if here's where I start and I make it my origin, you can see that this vector is shooting up in what appears to be quadrant 2. And if it's a quadrant 2, when we do this arctangent, whatever we get, we're actually going to add 180 to it. So let's see what we get. It'll be the arctangent of 6 over -2. And we're going to get some kind of angle, and we're going to add 180 to that. So let's go to the calculator. So we'll have the arctangent of 6 over negative 2. And then when I do control enter, we get this. But again, we're going to add 180 to this answer and see what we get. So it's going to be 108.435. So 108.435 degrees. Okay? Which looks like it is, because if you were to look at this like the unit circle, from 0 degrees you'd have 90 and then a little bit more to show that total of 108.435. Okay? Just like you would over here. If I made this my origin and I went from 0 degrees up to the angle, this does look like it is in fact that 38.660 that we got from before. Okay, so let's do the next one. We have arctangent of negative 3. Remember, it's always y over x. Otherwise, rise over run, which you are used to by now whenever you did algebra 1 of rise over run. In case you haven't made that correlation yet, tangent is the slope. Okay? So let's go ahead and see what the calculator gives us. But before we do, is 6 negative 3 in quadrant 1, 2, 3, or 4? So if I were to make this my origin, I'm going to envision that the vector is shooting in quadrant 4. Okay? And no matter where that is, it's still going to show me that it's shooting into quadrant 4, which we know we're going to leave as is. Okay? So let's go ahead and go to the arctangent of negative 3 over 6. So control divide negative 3 over 6, and then I get negative 26.6. So I can leave this, because it's in quadrant 4, as, let's see how many decimal places we have, 565. So negative 26.565 degrees is going to be that directional angle. Which, if you do look at this as unit circle, starting here at 0 degrees, it does look like it's traveling in negative 26.565 degrees. Okay, and now our last one. Our last one's going backwards. So we weren't given the vector so that we could figure out the components. Nor were we given the components first. We're working backwards as far as magnitude and direction. Okay. So magnitude and direction, if you recall that if you wanted to find the x component of a vector, okay, so you have x, y, and if you wanted to find the x component, what you're going to do is you're going to multiply the magnitude by the cosine, since x is cosine, of that angle. Okay, so it would be, in this case, 14 times the cosine of 135 degrees. That would be your x component. And the y component would be 14 times the sine of 135 degrees. And then you would have your vector drawn just like this. Okay, so let's see what we get with the calculator with 14 cosine of 135. Okay, so 14 times the cosine of 135 degrees, it is in degree mode, and we get negative 9.9. Okay, so negative 9.9 is what we're going to put into that slot, and let's go ahead and see what would that be to a little bit more decimal places. So 899 is what we're going to have. So negative 9.899 are is the x component. So now let's do the same, but this time we're going to do the sine. We're going to find what is the y component going to be. So we'll have, control clear, it'll be 14 times the sine this time because it's y, and it's going to be 135 degrees, and let's see what we get. We have 899, but this time it's a positive. And this makes sense that they're the same because this is traveling at 135 degrees. Okay, so that means if I were to create a unit circle, here's 90, 45 more, it's going to be shooting into the second quadrant, if you will. So I can just create a vector that comes from a point shooting into that second quadrant 135 degree direction, and I can show that this magnitude is going to be 14. So if you wanted to, you could label this as the magnitude is 14 units. Okay? And because of the fact that it has this 135, you know that it's going to go from 0 degrees all the way to this would equal 135 degrees. But again, all we have to draw is just what you see here with that red vector. Okay? And that's it for 1 through 4.